Hello, this is Mr. Precella, Anthony Precella.
And I'm Timothy Precella.
And today we're going to be discussing solving quadratic equations. We've already done some quadratic equations
In the previous assignment with factoring.
Yes, a quadratic equation is an equation, which means there has to be an equal sign in it, and there has to be an x squared. Okay, so we've already defined, we saw those, but let's go ahead and define it right now. Let's see. A quadratic equation, again, I'm not defining equation. Equation just means there's an equal sign. Let me fix this. Okay, a quadratic equation can be written in the form ax squared plus bx plus c equals 0. Now, if we want this to be a formal definition, what we want to say is make sure there's an x squared. So if a, b, and c are any sort of numbers, there's one number a can't be. And Tim, do you want to tell us what that number can't be?
0.
Yeah, if a were 0, it wouldn't be a quadratic equation. Do y'all remember what you call an equation that just has a variable with no exponent? It starts with an L. Tim, you want to tell us?
Linear.
That's right. Okay. So y'all solved linear equations in your earlier algebra classes, and we've started solving quadratic equations now. There are a variety of methods for solving quadratic equations. The methods that we'll use, you've already seen one of them. I'm going to say QE for quadratic equation. That's not any sort of formal math notation. That's my made-up notation. First method that we'll see is factoring.
We've already seen that.
Then the square root method is a method that you can sort of almost figure out on your own. And you'll see what I mean by that in a little bit. Completing the square, you might have seen that in another class, but we're not going to do that today.
It works so much better to introduce that with circles. So we're just going to delay completing the square until we get to circles.
And then the third method we'll see today is quadratic formula. Okay, the quadratic formula can solve any type of quadratic equation. Why do I mention that? Well, factoring doesn't always work because not every trinomial or quadratic equation, not all of those can be factored. Probably, x squared plus x plus 10 equals 0. Try to factor that. You'll never get it done. Okay? So, let's just
use irrational numbers, of course.
Let's go ahead and jump right in. And here's that homework screen. Now remember, you've got to first click and get a green check out beside all of these. These first two are going to be the videos that you're watching, okay? Then we have some Pearson videos. And I don't need to watch the video. I know how to do it. And so there's another Pearson video. And now we can start working on the problems. The first three problems are just like in your last assignment. Solving equations by factoring. So let me see. It says solve. So here's number 1. W squared minus 6W minus 16 equals 0. And I want to change this so that we have the green background. Doesn't really look green because I have this light on here. Do you think we need this light? Let's see what happens if I don't have that light on the camera.
Oh, I don't think that's very good.
That's not good at all, is it? Okay, let me go ahead and do that. Okay, so you just want to see it bright green. It's a dreary day outside.
That's what's wrong. It's so cloudy.
Yes, everything.
house-
Yeah, I'm sitting in front of a lot of windows, and it's normally bright, but not today. So, okay, enough talking. Let's see, how do we solve this thing by factoring? Well, the first number, the first coefficient, it's called leading coefficient, the one on the W square is a 1, so that's going to be pretty easy. We just need to come up with numbers that multiply together to give 16. Let me write them out. 1 times 16, 2 times 8, 4 times 4. The second sign is minus, so that means we need a plus and a minus. A positive times a negative to get a negative 16. And then we need the outer and inner terms to add together to give this middle term. So let's get started.
You're trying to create a FOIL problem that when FOILed out will give you back W squared minus 6W minus 16. Remember what you're trying to do.
And let's see. Okay, so 4 times 4, 2. Oh, yeah, we know the signs. 1 plus, 1 minus. I'll wait to fill that in a moment. A plus and a minus. I think most of us can figure out pretty quickly. 2 and 8. Why are we thinking it's going to be 2 and 8? Well, because those subtract to give us this middle term.
With a simple trinomial, ones where the leading coefficient is 1, the numbers you choose have to add or subtract to give you back that middle number. 2 and 8 subtract to give you 6.
Let's see, you want to FOIL it out and make sure we'd have W squared, then a minus 8W, and a plus 2W. Is that giving us a minus 6W? It sure is. And then minus 16. So just sort of a reverse FOIL. So now, set each factor to 0 and isolate the variable by doing the opposite operation. What you're saying is if two things multiply together to give 0, one of them better be 0. So that first set of parentheses, to make it 0, W would have to be a negative 2. To get the second one to be 0 and 8. So our solutions here are negative 2 and 8. Let's punch that in right here. Wait, let me do this. Oh no, not that. There.
You could turn off the camera.
Yeah, I
Y'all
guess
don't
I
need to see us
anymore. So we'll just turn off the camera. As soon as I punch this in. So, negative 2.
And you separate your answers with a comma.
Comma 8. Okay. Let's see. Oh, I guess I'll leave the camera on for a little bit longer. Let's see the next one. 2y squared plus 9y plus 10 equals 0. Well, second sign is plus, so 2 of the first sign. Oh, it's not a simple trinomial because there's this number here, but it's not too bad. 1 times 2. Now 10 is 1 times 10 or 2 times 5. So let me draw my parentheses.
Tony, should we switch it over so that you're recording what you're writing?
Oh, shoot. Oh, gosh. Yeah. Sorry. Let me lift this up. Right there. I'm sorry. So 2y squared plus 9y plus 10 equals 0. Yesterday when you weren't here, I did a whole problem on this with it before switching it over. So, let's see. So I wrote out the numbers that multiply together to give 2. I wrote out the numbers that multiply together to give 10. The second sign is plus, so 2 of the first. And there's not really any possibility for, or much, 1 and 2 is all that's going to do. So I'll say 1y times 2y. And I'm going to pair it with the 2 and 5. Now, if you remember that there can't be common factors other than 1 inside the parentheses, for the 2 and 5, you can't possibly put the 2 here because you'd have a common factor of 2. Also, you can't have 2 even numbers in the same. So this one, if I'm going to make it work with the 2 and 5, and that's what I'm doing, I'm making it work. I remember years ago when the student told me, you're just making these things work out. And I thought, oh wow, I'm going to remember that. And I told him, that's a brilliant statement. He was a hostile student, and the student sort of laughed when he said, you're just making these things work out. But that's what I'm doing, and it's a brilliant statement. So, let's see. Did I make it work out? Am I going to get a 9y here, 4y, and 5y? Yeah. So I've factored it correctly. Now I'll set each one of these factors to 0. And we get y equals -2. And 2y plus 5 equals 0. By the way, these arrows, hopefully you're getting the hang of that. When I'm doing that, your other teachers might have done this. -5 on each side. Tim, what do? Do you do an arrow or?
I don't even draw the arrow. I just do it showing with the tip of my pen.
Oh,
and
okay.
I say I'm transposing terms. When you transpose terms, when you move terms to the other side of the equal sign, you're basically changing the sign of the term.
So, -2 and -5 over 2. Those are the answers. -2, comma, -5 over 2. Okay.
Moving into the next.
Okay. Okay, so. Oh, well, how the heck did this one get there? It sure. I don't think there's much to do on this one. Is that a 5a minus 15? It's already got the 0 on one side. Just come here. Yeah. And let me see. So it's already got. We're skipping straight to this step right here. It's already got the factored form with a 0. So I just go and set each factor to 0. This might be the easiest problem today. What do you think, Tim?
So you transpose terms, move the 8 over, making it a -8. Then you divide both sides by 13.
Doing the opposite operation to both sides of the equation, beginning with addition and subtraction. The opposite of adding 8 is subtracting 8. The opposite of multiplying by 13 is dividing by 13. So, let's see. On this one, I'll add 15 to both sides. Divide by 5 and getting a 3. So -8 over 13 and 3.
Okay, switching back to Chrome.
Okay.
I gotta punch in. What did he say?
-8 over 13.
-8. I just used the slash.
Oh, wait,
13.
no, it's not.
No, it's not typing.
There.
-8 slash 13. Get out of the denominator.
The comma shouldn't go in the denominator of the fraction, so hit a right arrow.
And then comma.
3.
Is that what I wanted to type?
Yeah, I think it is. Oh, get rid of that. How do we get rid of that? There, okay. Now, the next method we're going to look at is something called the square root method. And it can really get to the screen there. The best way to illustrate that is if you just had something like this: x squared equals 25. I think most people can figure out the solutions here. Well, most people said probably 5. And I say, okay, so, well,
there's another one.
Yeah.
There's another solution.
So one solution is positive 5. The other solution is, and everyone, negative 5. So, plus minus 5. So what do we do here? Well, we're taking square roots of both sides. On the left, I just say drop the square. And on the right, you're going positive, negative, square root. So, theoretically, you're taking positive, negative square roots of both sides. Well, all it does is just drop the square on the left, take the positive and negative square root of the number on the right. I hear someone's phone going off.
I'm sorry.
Yeah. So, there's some downsides to this. It's got to be in this form. X squared equals a number. So the square root method works well if it's just
quantity squared equals a number.
You might have to do a little bit of work to get it in that form if it isn't already. Let's look at number 4 and see what it looks like.
Let's see. Number 4.
5x squared equals, is that a 35? Okay, well, it's not x squared equals a number, so...
Okay, wait a minute, let me switch over.
So we need to first get rid of this 5. We can do that by dividing both sides by 5, and when we do that, we have x squared equals 7. Well, and 7's not a perfect square, but we can still do what we did up here. Imagine taking square roots. It would cancel out the square. We've already mentioned how square roots and squares cancel each other out. And then take the positive and negative square root of the number on the right, 7.
This brings out a good point. The square root method will give us irrational solutions as well. When you're factoring, you don't get irrational solutions because when you're factoring, there's no irrational numbers inside the parentheses. So here's an advantage to the square root method. It'll give you solutions that aren't just rational numbers. They're not fractions or integers. That'll give us a positive or negative square root of 7.
So plus...
Come over here. There.
Well... Plus my... Are you moving the mouse? Okay.
Hold on. There. It's clicking there now.
Plus minus the square root of 7. Okay, number 5. 4x squared plus 20 equals 0. Well, we can write it in the form x squared equals a number just by moving the 20 over, so subtracting 20 and then dividing by 4. We have x squared equals negative 5. So it's in that x squared equal a number form, so taking square roots would cancel out the square here, so we just have x equals, take the positive and negative square root of the number on the right, but be careful. The square root of 5 can't be simplified, but there's a negative, and this might be the first time, depending on how your numbers have worked out in the past, this might be the first time that you've seen one like this, where you can't simplify the square root of 5, but you don't want to leave that negative there. anytime you have a negative under a square root, you might remember when I was doing these earlier in videos, I'd always put an I right off when I saw a negative under the square root. So I'm just going to say I square root of 5. You can't simplify the square root of 5, but don't leave a negative under the square root. Write that green negative as the green I. So plus minus I square root of 5.
So we're going to type in there. You go down to your toolbar, the plus minus hot button right there. And then we need a square root.
No, an I. Let's put the I.
The I, yes, okay. And then the square root.
You'll notice we don't hit spaces and we never use capital letters. If you start hitting spaces and it's in capital letters, it might not format it correctly and you might wind up getting an answer marked incorrect. Okay.
Next one.
Okay, let's see. What's number 6? Ooh. 2. Can you drag this way up there?
That's what we're trying to do.
Oh, you're moving that. Okay, that's fine. Okay, so number 6. Let me write it down. Ooh, I don't have any blue ink. All my really good markers are still in my office. Hey, this one might be blue. Is this blue? 2x minus it is 5 squared equals 21. At first glance, you might think, oh my goodness, what are we going to have to do? Do we need to FOIL this out or something? No. If you can write it, x squared equals a number. X squared equals a number. Okay. But if you can't, if there's parentheses in it, if you can write it in the form parentheses squared equals a number, you can still do the same thing we did. Drop the square on the left. Take the positive and negative square root of the number on the right.
Remember I said the square root method can be applied as long as the equation can be written in the form a quantity squared equals a number. And yes, we have something being squared, that 2x minus 5.
So I'm dropping the square on the left. We still have the 2x minus 5.
And what do we pick up on the right?
A plus minus square root.
Okay.
Right? So if you wanted to write out, okay, drop the square on the left, take the positive, negative square root of the number on the right. Okay, the only difference is here, we're not finished. When you're solving an equation, you always want x equals some number. Well, we don't have x equals yet, but we know how to get the x by itself. What would we do? We'll
slide up a little bit.
Oh, okay. We will move the 5 over by adding 5, so we have 2x equals 5 plus or minus the square root of 21, and then divide by 2. So 5 plus or minus the square root of 21 all over 2. You want to type that in, Tim?
Switch.
Oh, we don't have to type it in. It's multiple choice. This gives you an idea of what my math lab was like way back when it first started. Is it C? Heck, it's C. It's almost the only one with the plus minus. Yeah, okay. Yeah. They won't all be multiple choice, as I'm sure you know.
Oh, here's another one.
Here's another one, multiple choice. Let me get a new sheet of paper and write it down. Is this number 7? Z plus 3 squared equals, is that a negative 11? Yes. Okay, let's, well, isn't that form quantity squared equals a number? Isn't that what you said, Tim? So I will drop the square on the left and just have z plus 3. I'll take the positive and negative square root of the number on the right. And, well, there's a couple of things we need to do here. We need to simplify the square root of 11, the square root of negative 11, and we need to get the z by itself. I'm going to do it like this. I'm going to move the 3. That'll get the z by itself. then plus minus. Now,
Can you simplify the square root of 11?
you can't simplify
No,
the
it's a
11
prime
part,
number.
right?
But what can you do? What do you have to do because of that negative under there?
You've got to write it as an I. This green negative. That's why I put a green I there. Hopefully y'all can tell the colors. So, negative 3 plus minus I square root of 11.
So we come back here. There. Negative 3. Hey, I think it's the first one. So negative 3 plus minus I square root of 11. There. Oh, and notice, if it's a multiple choice question with fewer than 4 options, you only get one shot. Notice down here, but it says final check. You don't get a second choice to try to, if you choose the wrong answer, you don't get a second choice. You got to say similar problem and redo it. If there are 4 options, then you get 2 shots at choosing the correct answer. But if there's 3 or fewer options, then you're only going to have one choice or one chance. But we got it right.
So square root method is good for problems, in a certain format. X squared equals a number, or quantity squared equals a number. Factoring, well, it's got to be factorable. We need a method that can solve any type of
Going back
quadratic
to the square root method, though, if the equation is not set up in the form quantity squared equals a number, that process completing the square can be used to write it in that form, okay? But it's never the quickest method of solving. The quadratic formula, which we're about to see, will always be better than completing the square, or quicker at least. So we'll see completing the square when we're working with circles. So, but just delay.
And you can derive this formula by using completing the square, but right now we're just concentrating on solving quadratic equations, okay? So here they are. I'm going to write out the quadratic formula. The solutions of ax squared plus bx plus c equals 0. Now remember, we're assuming that a is not 0, because then it'd be a linear equation, are given by, if someone says state the quadratic formula, what they're probably wanting you to say, x equals what I'm about to write right now. Here's what the
fraction part.
Negative b plus minus the square root of b squared minus 4ac all over 2a. Every time, I know at first it can look intimidating, but every time I write this down, I use it, I'm going to write it down. And just by the time you're through doing these examples with me, you will have basically got it memorized. Okay?
If you don't already have it memorized.
Yeah. Okay? So, negative b plus minus the square root of b squared minus 4ac all over 2a. Now some observations. I always think it's easier with a fraction if that bottom number is a positive number. You never want to see a fraction with a negative number in the bottom. So, I'm going to assume that a is always positive. And if it isn't, I'm going to rewrite the equation so it will be positive.
Either multiply through by -1 to change all the signs, or move the terms to the other side. But you want a to be a positive number, okay?
And theoretically, it doesn't matter. It could have been 0 could be on the left. 0 equals ax squared plus bx plus c. And we'll see that before it's all over, I'm sure. Okay? So now, let's look at number 8. Tim?
Oh, we got the switch. Yeah. Okay.
Okay, y squared. Sometimes students say, well, wait, could I factor this instead?
Minus 12y equals -34. And notice the instructions say use the quadratic formula. And so, Tony, you were saying if you could factor it,
well, theoretically you could if it's factorable, but this isn't factorable.
If it says, what I've noticed is if the instructions on my math lab say use the quadratic formula, they're basically telling you it's not factorable. You could try to get it factored, and it's got to be in the same form. You got to get it set equal to 0, whether you're factoring or the quadratic formula. But if it says use the quadratic formula, that's their way of saying don't waste a lot of time trying to factor it. It's not factorable.
So let's see. Let me lift this up a little. Now, well, it needs to be in the standard form with a 0. And so the way we'll get it written with a 0 is by adding 34 to both sides. Y squared minus 12y, and adding 34 to both sides, moving that 34, changes it from a minus 34 to a plus 34. See, think about it, you can't factor this. 1 times 34 and 2 times 17, those are only numbers that multiply together to give you 34, and none of them are going to get a 12 for the middle term. So, I'm going to write out A equals B equals C equals. So, A, B, and C are numbers. So sometimes students will say A equals Y or something like that. No, it's the number.
If you don't see a coefficient, you always assume that coefficient is
1.
Right.
B is a negative 12.
You take the sign.
And C is 34.
A positive 34. Where this room that we're in right now has 4 sick cats that are quarantined in here away from the rest of our cats. So if you hear cats scratching and meowing, they're feeling better today. They're making a lot of noise.
Yeah.
When they were sick and just sleeping the whole time, that was easier. But now they're really beginning to make a lot of noise.
It's nothing serious, just an upper respiratory thing. But
we don't want our other cats to get it.
Okay.
So as Tony said, every time you do a quadratic formula problem, rewrite the formula for the problem, identify your A, B, and C, and then rewrite that formula. That way you'll have the formula memorized by the time you're through doing the homework.
Okay. You know what? I screwed up.
You did?
I should have written this in red. Or some other color. Let me show you why.
Oh, okay. Because then you can put...
In place of the B, I'm going to put a blue negative 12. So there's still this red negative from the formula. And then a blue negative 12. Negative is a positive. Y'all see why I'm writing a positive 12 there when it says negative B? There's a negative from the formula, and then a blue negative. So negative 12, negative 12.
I say the opposite of negative 12 is a positive 12.
Right. So that negative B always just changes the sign on B. Plus minus the square root of... Now, some stuff I like to do in my head, or else just I don't actually show the work. The B squared and the 2A I'll do in my head or punching on a calculator if the numbers were too big. Like B squared. Negative 12 times negative 12, that's a 144. If you doubt me, pull up a calculator and punch it in. Okay?
Negative times negative, remember negative times negative is positive.
Then we have a minus 4 times A times C. So A is a 1 and C is a 34. All over 2 times A. The 2 times A I do in my head. 2 times 1 is 2. I think it's good to show steps, but there are sometimes when showing too many steps just bog you down, and you're going to see exactly what I mean when we finally get to logarithms. The more steps you show when you're expanding and condensing those logarithms, the harder it is, okay? So sometimes students say, oh, I want more steps. There are times when you don't need too many steps, okay? So, let's switch... let me pull up my calculator. Hold on. I'm using a silver edition.
Isn't it? 4 times 1 is 4.
Well, I just want that. I do this for thought process.
Oh, okay.
Okay, I'll punch in what's underneath here. Okay, so let me turn this on. I'm simplifying under the square root symbol. 144 minus 4 times 1 times 34. Okay, so I'm just punching in everything under the square root symbols.
8.
Okay.
It's 144 minus 136.
So I'm simplifying all of this. I punched in the stuff under it, and we got an 8. So we have square root of 8. Now, how the heck do we simplify square root of 8? Well, that was the first stuff we did this semester.
Is it a perfect square? Is 8 a perfect square?
No, but I know a perfect square that divides into it.
What's the biggest perfect square that divides evenly into 8? It should be obvious.
A 4. 4 times 2. So, let me move this over. There. And now I have a square root of 4 in purple. So that would be a purple 2, square root of 2. So the first thing I do when I'm doing this quadratic formula is simplify that big square root. And that's what I've done here. I use my calculator to punch in the stuff under it. That's where I got the 8. Then I simplify the square root of 8. Okay? So now I'm going to rewrite it all in one color, replacing all that circled stuff with
move the paper
2 square root of 2.
So he's replacing that radical that he simplified as the square root of 8 and 2 square root of 2.
Okay.
And all over 2.
And we've already seen one way you can simplify something like this where there's just one number on the bottom, and that's just to separate it like that. Here's another way you could do it. Looking at the 3 numbers here.
The 3 numbers outside of the radical.
Yeah, that aren't under a radical at all. What could I divide all of those by? Well, just divide all 3 of those by...
The biggest number that divides evenly into those numbers is?
2. Yeah, I was waiting for you to answer that question.
Okay.
12, so I'm dividing by 2. 6. 2 over 2 would just be 1. Hey, 2 over 2 is 1, so I don't need a fraction bar at all. I will turn this into a circle thing. Well, not really a circle. So 6 plus or minus square root of 2. Another way you could do this is say, okay, factor the 2 from each of these and cancel with this. But again, your goal is to sort it. Speed is part of the goal. Right, Tim?
I guess so. I always factor and cancel. I always show it.
Okay, well, that's it there. I'm going to hit the fraction bar.
No, we don't
need a fraction bar, do we? So just 6 plus or minus...
Plus or minus
the square root.
Remember, we're using the square root. What about that symbol there? That's for the cube root or fourth root or something. We want a square root of
2.
2.
Wow. 20 short years. We're going to be through. We're just flying through these. Okay, number 9.
Oh my goodness. So
2x squared
minus 5x
minus 5x
equals 1.
equals 1. If you want to see me doing more of these videos, or one of us doing more of these problems, our Math 1314 playlist on YouTube, I'm just redoing these, making a new video, just because I noticed that the video I had been using, I made in 2014. It's now 2021. I was like, but it's sort of funny to watch it. The problems haven't changed. Quadratic formula hasn't changed in my lifetime. Hasn't changed in your lifetime either. So,
and there's a link to that YouTube video under announcements on
the playlist.
That YouTube playlist under announcements. I think it's on both. Well, I know it's on Canvas. Okay, the announcements on Canvas. Or else it's the announcements on my lab. It's one of them.
Mm-hmm. Okay, so 2x squared minus 5x equals 1. Let's switch it over. Well, it's not in the standard form that we need it in. It needs to have a 0 on one side. So I will move the 1 over.
Notice it's got to be written as if you were trying to factor it. And once again, if this were factorable and you solved it by factoring, you'd get the same answer.
I messed up. You see what I did?
Yeah,
I put a plus 1.
What should that have been?
Should have been a minus 1.
That's right.
Y'all see that? I'm subtracting 1. So can y'all read that? It's 2x squared minus 5x minus 1 equals 0. Now, let's write down the quadratic formula and plug in.
We'll want to identify A, B, and C also.
You are certainly right. So let's write it out. A is 2.
The number in front of x squared.
B is what?
Negative 5.
Negative 5.
The number in front of x.
Be sure to include that negative. And C is negative 1.
That's right.
So we'll start plugging in to the quadratic formula. Negative.
Always write that plus, minus, and radical right there when you did that.
Oh,
You already
okay.
had that in there.
Oh, okay.
Then I have to.
Okay, so negative B, there'd be a purple negative, a red negative, 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 opposite
of negative 5 is a positive 5. So just change the sign on B.
And now the B square is the thing I do in my head. Negative 5 times negative 5, that's a 25.
Negative times negative is positive again.
Minus 4 times A times C. You might notice I put parentheses there, but I don't do the parentheses when I'm punching it into my calculator. I just hit times. Minus 4 times A times C all over. What number's going to be in the bottom?
2 times
2.
2 times
is
2 is 4.
4. Okay. Now, I simplify under the square root symbol.
Let me pull up that little calculator of yours.
Okay, you want to punch it in, Tim? You can use the keyboard if you don't. Oh, clear up that.
I'm going to clear that out. 25 minus 4 times 2 times negative. Remember, you have to use the negative sign. Don't use the minus sign. 1 equals.
Oh, I like that.
Negative times negative, that became a positive. So it was a 25 plus 8. I agree with that positive 33.
Now, why am I saying I like that? Can we simplify the square root of 33?
It's not a perfect square. Are there any perfect square
4,
factors?
9, 16, 25. No.
No.
So I think we are almost finished with this one. Oh, wow.
20 short years, we'll be through with this homework.
5 plus minus the square root of 33 all over 4. That can't be simplified. Okay?
Oh, well, notice there's no common factor. You don't even see a number outside this radical. So what's the coefficient on the square root?
A 1.
1, 5, and 4. What's the biggest number that divides evenly into 1, 5, and 4? Well, the only number, the only positive integer is 1, so you can't reduce it. Oh, wait.
So
There, here. So let's see. Okay, y'all tell me. What should I click first to type in that messy fraction?
the fraction.
That's right. You'll see me using the slash for a fraction, but I only do that if it's number over a number.
Like 2/3, 2/3.
But if it's anything else, then you need to use that fraction bar to make sure you're typing in what you want to type in. Now we're going to type on top. What do we have?
5
plus minus.
wait.
Oh, I put.
I hit it and you did it.
Okay. Well, you go ahead.
No, I'm not doing it anymore.
Okay, so the square root
of 33.
of 33. And then I come down to the bottom, and what have I got down here on the
4.
bottom? A 4. Let's check it.
Now remember, if you get it wrong, you can try again, try to correct it. And if you get, just at the end, if it's still wrong, do similar exercise. There's no reason not to have 100 on this. Okay, number 10. There's only 15 problems. We are going. We are flying. Okay, let's see.
That means we have 6 problems left.
I know.
10, 11, 12,
and the last one has some fabulous fractions in it. Good.
Hey, this just says solve for x. It doesn't say use the quadratic formula. Maybe we can factor this. What do y'all think? It's
1 times 5. Is there any way you're going to get that? The second sign is plus, so 2 of the first, so no. Okay? Even if the second sign had been minus, you couldn't factor. So from 8 through 15, it's it's all just quadratic formula. Okay? Well, at least it's in,
let me switch it over.
it's in standard form, so I can go ahead and label A equals B equals C equals A is 1. B is what? A negative X? Sometimes students do that. No. The A, B, and C must be numbers.
So you don't
negative 1 and C is 5. So negative B plus minus the square root of B squared minus 4AC all over 2A. So I'm going to start plugging in negative B. Let me see what color I'm using. Negative B. Negative would be a positive 1. Oh, I was supposed to put the plus minus and the square root here. I didn't. B squared. Negative 1 times negative 1 is 1. Minus 4. Now I use parentheses just to distinguish them. 4 times A times C all over 2 times A. When I put a 1 in for A, is that going to be a 2? And let's simplify under this square root symbol. And this some of you might be thinking, well, I don't need to use a calculator for this little simple calculation. Okay, this is a way to show my thought process.
turn it on. I'll clean off.
1 minus 4 times 1 times 5. 4 times 1 times 5 is 20. 1 minus 20 is a negative 19.
Oh, I like that 19. Can we simplify the square root of 19?
No, but
it's a prime number. 19's prime. You're sure not going to simplify.
Oh, and here comes one
of our cats.
Okay. This negative right here. Oh.
No, but that. Okay.
Okay.
I'm going to move.
Okay.
Thank you.
Oh. So,
sorry about
we can do one thing here. We can rewrite that square root of a negative with an I. So we have a red I square root 19. Okay? Oh, this one's going to fall out pretty easily. We have a 1. I'm writing it all in one color now. Plus minus I square root of 19 all over 2. You can't do anything to simplify.
Well, wait a minute. What I would do, if I have a fraction with an I on top, I do what we did with that in that second homework assignment with a number like this. I separate it 1 over 2, and then square root of 19 over 2, and I stick the I out on the side.
You write it like this?
I think my math lab will take both forms right now.
Right now.
But if it's but I've discovered it's a multiple choice question, not those other multiple choice questions we had earlier. If there's an I on top, that's not going to be one of the 4 options or one of the multiple choice options. They will split it up.
Like that.
Okay. But y'all have practiced using either form, so
I'm going to try. Oh.
Wait. Oh, no, I did that, didn't I? Oops. Hold on. There and there.
Okay. We're going to click on the box.
Oh, I better click on the box. Right.
I want to see. I'm curious. Will they take this? It's just one big fraction. One. Because the other day there was the problems that where they no longer took. Oh.
Wait, did I do that?
Yeah,
One?
you moved the
Oh,
mouse.
I
Okay, then you go ahead.
Okay, so it's a
I square root of 19.
I square root of 19. And on the bottom, what is
A 2.
A 2. You see, they say, let's see, where is it? Check answer.
Okay.
So they did take it all as one fraction. They would have taken it split up also.
Oh, yeah. Definitely the split up. So, number 11. 2x squared minus 11x equals 1. 2x squared minus 11x equals 1.
Let's see, write it.
Well, I'm going to have to move the 1 over. 2x squared minus 11x. I'm subtracting 1 from both sides. Equals 0. So A is 2. B is negative 11. C is negative 1. And I'll write down the formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. So b is a negative 11, so we have a green negative and a purple negative. Negative is positive. So change the sign on b. Plus minus square root fractional. Okay, b squared, negative 11 times negative 11. I would write that as just a 121. If you can't do that in your head, just punch it in your calculator. The 4 times a times c, this is one where you can basically do it in your head probably. I'll write it out anyway. 4 times a times c all over 2 times a. What should we have on the bottom?
2 times 2 is 4.
4. Okay. Well, let's simplify into the square root.
So, pulling it up. As Tony said, you can probably do this all in your head because it's numbers 4 times 2 times negative 1.
So that's going to be a plus 8, isn't
Yep,
it?
negative times negative, that's going to become a 121 plus 8,
So
which gives us a 129.
And so, ooh.
129, I know it's divisible by 3. Let's see. Try dividing it. 129 is not a perfect square. We'll agree on that.
3 isn't a
3
perfect.
is it, but maybe the number it'll give
Oh, okay.
will give us a number that's a perfect square. 43.
I don't think
43 is a prime number.
Yeah.
3, there's no perfect square factors. So the square root of 129
4.
can't be reduced.
Here's my thoughts. I'm going through. Are there any perfect squares? 16 certainly not.
3 times 43.
25, 36. Yeah, there's no perfect square. Okay?
So the square root of 129. What I've discovered with my math lab is that if there's a number that's sort of messy, an odd number under a square root, and you're like, well, can that be reduced? If it's some odd number, strange, by odd I mean just strange looking number that you can't think of any perfect square factors right off, probably there isn't one. And like this one here. So is there a common factor we can factor and cancel?
Nope.
1, 11, and 4? No perfect square factors. So
If the square root symbol can't be reduced,
then the fraction itself
just
can't
leave
be
it like
reduced.
that. Well, theoretically, you could always separate it, but I don't see. Okay, I'm not going to help you punch it.
Okay,
slow
what
it
should I do?
Fraction bar.
Fraction bar. And then what was
11
Plus or
minus the square root of 1.
the square root of 129. And on the bottom,
over 4.
oh no, I didn't type in the 4, did I? 4. Yeah, I didn't hit the key hard enough.
Equals. Okay. Now, let's see number 12. X squared. Is that equals?
Equals 4x minus 13.
I wonder if I'm going to finally get one like this. We got to get it in that standard form with a 0 on one side, but I'm not going to move the 4x and the minus 13.
Why not?
I mean, oh yeah, you're right. I'm not, okay, forget it. I'm going to subtract the 4x and add the 13.
Remember, we said we wanted a to be what sort of a number?
Pause.
A positive number. So you think, well, I can move the x squared over, that's only one term. Then you'd have a negative x squared plus 4x minus 13. So you don't want to do that. I move the terms around. When I have to move the terms, I move them around in a way to make sure that a stays positive.
Yeah, so we still haven't seen one like that where you move what?
Once we get to the square root problems, we will.
Okay, so let me write down the formula. Negative b plus
But
minus
that's another homework assignment.
square root of b squared minus 4ac all over 2a.
Hey, you want me to do it? You want to switch
Sure.
places?
Okay. Oh gosh, here.
Oh, goodness.
So we got our red. Oh, you write on lines. I never write on the lines. You see, there. Okay, and so negative b, the opposite of negative 4 becomes a. What color is that?
That's just
Black. Okay, so the opposite of negative 4 becomes a positive 4. And b squared.
Negative 4 times negative 4, that is a 16.
16. You're right, Tony. A positive 16. Seems like all the problems today, the b values have been negative. So, but remember, negative times negative is positive. Minus 4 times a times c. A is a 1. And c is a 13.
My brother had a teacher at a young age that told him to put the little mark at the end of the square root.
Oh yes, that
And he
means it's
still
over.
does that
That's the
sometimes.
end of it. I always
No, you did it up there.
No,
Or is
you wrote
me?
that.
You see, I don't do that because I'm afraid it'll look like an exponent of 1.
all over 2 times a. 2 times 1 is 2. Okay. You see, I write as if there are no lines. I need to be more careful. Make it more. Let's see. Look at this. We have a 16 minus 4 times 1 times 13 is 52. So we have a 16 minus 52. Oh, clear off all that. Okay.
16
Minus 4 times 1
times 13. Okay,
Yep, it's a
16
negative.
minus 52, negative 36.
So this thing here is a negative. I mean, it's a square root of a negative 36. So we have here's my fraction bar. I'll get back using the lines there. So I have a 4.
Now let's simplify that square root
Plus
of negative
minus.
36.
Hey, 36 is a perfect square. I know what the square root of 36 is. It's 6. But what do I have to do? Because of that negative? Stick on an I.
Square root of a negative is an imaginary number.
And in the bottom we have a 2. And if we type in this answer for our final answer, I'm sure they're going to say, my math lab would say, no, you need to simplify it. If
I might just say wrong. what I do, if I have a fraction and there's an I on top, I split up the way you did.
Put the little universal split up marks.
The universal split up marks. Okay, there and there.
Yeah.
So it's 4 over
Oh.
2 plus or minus 6i over 2. And then we can reduce the fractions individually. 4 divided by 2 is 2 plus or minus 6 divided by 2 is
3.
3.
Is that
Yeah. No, I'm
Oh.
still waiting for the students to answer back, but they can't. But
2 plus or minus 3i. Let me get this little. Then I'll type it in. 2 plus minus 3i. Okay. Now number 13.
Number 13. Do you want me to do another one?
Sure.
Well,
Just start writing, I guess, on that amount of loose paper.
oh no. Okay, let me write this problem down. This is number 13. And let's see, what does that say?
R squared plus 3r minus 1 equals 0. Even if it didn't say use the quadratic formula, you could convince yourself pretty fast it can't be factored.
Switch over.
Okay. Notice it's already in the standard form, isn't it? So.
Oh, we're using real old paper.
Oh, I think.
It's sort of vintage, you might say.
Yeah,
I wonder if World Fiber is even still in business.
This is paper that we found in our office when we were moving from the old building to the new. This paper's from the 90s. And we filed it away in our filing cabinet. And
yeah, well, it's already in standard form. This is Sunday for us right now, and it's a cloudy, rainy Sunday, but let's try to get going, Tony, so that we don't spend all Sunday.
Get going, Tim. Oh,
Okay.
are you going to do it or not?
I'll do it.
Oh,
Let's identify our A, B, and C first. A is equal to
1.
Okay, I agree. The number in front of R squared. B is equal to
3.
Hey, B is positive, you
Yeah.
see. And C is?
Negative 1.
I agree. Rewriting the quadratic formula. Negative B plus minus the square root of B squared minus 4AC all over 2A. So we have a plus minus. Let me write my big fraction bar. And my plus minus square root. I hope this, I'm not going to put the little mark that ends the radical.
Good.
Okay.
Aesthetically, it just looks so much better with that.
No, it looks good. It looks better with it because then you know that's the end of the radicand. Okay.
I know it's the end and I don't need the mark.
Negative B. The opposite of 3 is a negative 3. And B squared.
9.
3 squared is
3.
9. And then minus 4 times A times C.
A is positive 1.
I did it by habit.
Oh,
When I
okay.
extended the radical, I can't stop that.
Okay.
A is positive 1, and C is
Negative 1.
negative 1, I agree. And what about 2 times A?
2.
2 times
times
1
1
is 2. Okay, I agree with you.
And you know what? Let's simplify into that square root without a calculator.
Negative 4 times 1 is negative 4, times negative 1 is positive 4. So we have a 9 plus 4, which gives us a
13.
I agree. We have a square root of 13. Are we going to have an I in our answer?
Nope.
No, because there's no negative under that radical. Can we simplify the square root of 13?
Nope. 13's prime.
Prime
Nothing
number,
divides
can't
into
simplify it.
other
So
than 1.
we have,
Negative 3.
so we have a negative 3. We have that 2 on the bottom. And what have we got right here?
A square root of 13.
The square root of 13. Can we simplify that? No, but since you can't simplify the square root of 13,
if you don't have a number in front of that radical, you cannot factor and cancel. So, I agree. Tony said if you can't simplify the square root of 13, you can't simplify further. There it is.
Okay, so
Why don't we use these purple pens? I like this purple
I've been
pen.
using
Oh,
it.
okay.
So it was -3
He typed the fraction hot button first.
plus minus
the square root of 13 all over 2. Okay.
Only 2 more to go.
I know. I bet you
so
these are really good.
This one's going to illustrate what I wanted to show.
14, okay.
-2x squared equals -7x plus 12.
Uh-oh, it's not in standard form. Switch it over.
Okay.
Okay.
Lift it up. And what did I mean by saying this is going to illustrate something I want to show?
You need it set equal to 0. I guess you can move these terms over and get the 0 on the right. But then look at what A would be.
A -2.
A would be a -2. Remember, we said we wanted A to be positive. So I'm not going to move these terms on the left, on the right over to the left. What am I going to do?
Move that -2x squared over to the right.
Equality is reflexive. A equals B is the same thing, or I should say, W equals Z is the same thing as Z equals W. So I can just move that over. I'll have the 0 on the left. That -2 will become a
+2.
Okay. I'll draw the little arrow the way Tony does it. Positive 2x squared, and I still have that -7x plus 12. And now identify our A, B, and C values. A is equal to 2, I agree. B
is -7.
Yes.
And C is 12.
Okay. And writing down our quadratic formula. Have you got it memorized yet?
I bet they're pretty close to it. -b plus minus the square root of b squared minus 4ac all over 2a. And you're about to start noticing in the homework, there'll be problems sometimes that are just review of stuff like this quadratic formula, so you don't get a chance to forget it. Okay? I think in the next homework assignment, problem number 15 is just to solve by quadratic formula. Okay? So let's plug in.
-b, the opposite of -7 becomes a
+7.
I agree. B squared.
-7 times -7 is 49.
Okay. And then a minus 4 times A times C. A is 2, I agree. C is
12.
okay. What about the denominator? 2 times A.
Oops.
2 times 2 gives me
4.
4, I agree.
I'll pull up the calculator and let's see. 49 minus 4 times 2 times 12, that's 8 times 12, 96, and 40, -47.
49 minus 96, I agree with the -47.
But you can simplify that square root of -47.
Is 47 a perfect square? No. Is there a perfect square that divides evenly into it?
No, but
47 is prime, so that's nice. But what do we have to do with that negative?
put it as an I.
So we have,
7.
I'll write it here.
Oh.
I'm just going to write everything in black now. 7 plus or minus, I'll bring out the I. I have a 47 underneath it, under the radical, and down here I have a 4. And my lab will take this form here. I'm pretty sure they will. But if you have a fraction with an I, and they want it in standard form, A plus or minus BI, what would you have to do?
Separate it 7 over 4 plus or minus square root of 47 over 4. And where do I put the I?
Out beside.
Out beside it.
So either way it'll take it.
Let me move that over there. Either one of those. So which one do you want us to type in?
I'm going to type in... Oh, I guess I'll type in the second one just to show. That'll go 7/4.
Get out of the denominator before you click the
right arrow.
Just type it up.
Plus minus. I'm going to use the fraction bar. Ooh, wait, what did I do? Let's see. Okay, hit the fraction bar twice. Okay.
That's
Is that a square root of 47?
Can you see it there? Yes.
Over 4. Right arrow to get out of that fraction before I put the I. If you're going to write it like this, you might want to just put the I up there in front of this the square root of 47. But several ways to write your answer. And before we do the last problem, I always review multiplying fractions at this point.
I'll let you
want to slide. Okay. So I'll come around like this.
I'm just glad that the cat's got quiet.
Yeah.
To get a little...
Okay. Okay. When you multiply fractions, I'm just reviewing some multiplying fractions.
Take the paper off.
Yeah. Okay. Okay. If we have something like this, 2/3 times 3/4. One way you can multiply these fractions is to just multiply straight across. 2 times 3, 3 times 4, and then reduce that answer. 6/12 would be 1/2. But do y'all recall doing some cross-canceling when y'all first saw fractions? You do something like this. 2 goes into 4 2 times, and then you could cancel the 3's, and just what would you be left with? Well, just a 1 on top and a 2 on the bottom. So with fraction multiplication, you can cross-cancel. Suppose we had an integer times a fraction, something like the number 12 times 5/6. Well, you could always think of this as 12 over 1, and can I do some cross-canceling there?
Mm-hmm.
Yeah, 6 goes into 12, 2 times 5 is that a 10?
What happened to the denominator?
Well, there's just a 1 on the bottom.
And
now
show the denominators are 1.
Suppose we had 30 times 1/12. 30 times 1/12. Well,
that's the biggest number that divides evenly into 30 and into 12.
Yeah.
2 will go in evenly, but I bet there's something bigger.
6. If you divided both of these numbers by 6, 6 goes into 35 times, 6 goes into 12 2 times, so your answer would be 5/2. I just want to make sure you remember this cross multiplying, because I think that this cross canceling. I think this is not that difficult to do. Okay, so when I look at the next problem, it might not be immediately obvious why I'm saying that, but let me write this down. It's problem 15. 1/7 x squared plus 1/21 x minus 1 equals 0. Well, It's in standard form. Ax squared plus bx plus c equals 0. So I guess if you wanted to jump right into it, which you shouldn't, with a equals 1/7, b equals 1 over 21, and c equals -1, you can get it right. But there's really no reason why you should ever have to use fractions when you're doing using the quadratic formula. Since this is an equation, you can multiply, divide both sides, as long as you're doing both sides. So
you can multiply both sides by any number you want to, except for 0. You can't multiply by 0 because then everything would just become 0 equals 0.
But like up here, I could multiply straight through by 30 or 12, but I want to multiply by something that'll cancel both of those. What number would I need to multiply straight through by? Like if I multiplied through by 7, that would cancel out this 7, but it wouldn't cancel the 21. It would leave what number in the bottom if I put a 7 there and cross cancel?
21 divided by 7 is 3. You'd be stuck with a 3 there. So 7 is not the number you want to multiply.
What could I multiply straight through by that would get both of these to cancel?
21.
Yeah. Let me show you what I'm doing. I'm going to multiply straight through by 21.
You're distributing that 21 over every term.
Even the 1 gets multiplied by 12. I just put a dot there.
No, 21.
Excuse me. 21. Ooh, wee. Okay, I'll do it right here. And right here gets multiplied by 21. Why did I choose to multiply by 21? Well, look at this. 7 goes into 21 3 times. 3 times 1. That would just be a 3. I think that looks a lot better.
That 1 in the denominator there, you don't show denominators of 1. Tony's gotten rid of the fraction.
And
now
right
we'll have
here,
an a value of 3.
Okay, I'm carrying down this plus sign. It's this one here. And look at how nice this looks. Okay, I can cross cancel the 21s. 1 over 1 is just 1. I don't need to write the 1, but I'll go ahead because that's the b value. Then a minus. 21 times 1 is 21. 0 times anything is 0. So by multiplying straight through by 21, we get a pretty basic looking quadratic formula problem. A is 3, B is 1, and C is -21.
Before we go on, to decide what to multiply through by, you multiply by the smallest number that both of those denominators divide evenly into. What's the smallest number that 21 divides evenly into and 7 divides evenly into? 21.
Okay. I guess you could do it if you multiply through by 7. That would leave you a 3 here.
Then you have to multiply through by 3.
So, writing down the formula. Negative b. This is the last time I'm writing the formula today. All over 2a. So starting to plug in. Negative b, so that's a -1, plus minus the square root b squared. Well, it don't get much easier than that. 1 times 1 is 1. Minus 4 times a times c. A is a 3. C is a -21. All over 2 times a. 2 times 3 is 6.
Okay, so pulling up the little calculator. Right there, let me clear that off. And it's a 1 minus
Oh, pardon me.
4. Where's times? What do I do? Times 3
Here. Times
-21.
Oh, no, you hit subtract.
Okay. So I gotta use the
Plus minus.
there.
Uh-huh.
Not really a plus minus, it's just there.
Oh, yeah, it is in the plus. 253. Ugh.
Well, 12 times negative times negative is positive. 12 times 21 is 252. And then you add the 1, so 253.
Well, let's see. Certainly
Not divisible by 2 or 3. Sometimes, if it's an odd number, try dividing it by 3. Does the number you get turn out to be a perfect square?
no. So it's not divisible by 9. What about? No, I've actually the wrong thing. 253 divided by. I'm wondering about 49.
What did I say earlier? I said if it's just a strange number that no perfect square factors pop out to you, odds favor, for my years and years of experience with my lab, odds favor if it's some number like that and you're just not really sure it's not a perfect square and you have no idea what the largest perfect square divisor is, I bet there isn't one.
Mm-hmm. So I think the square root of 253 can't be simplified.
Let me see something. 253 divided by 3. 3 isn't a perfect square. You see, it didn't even go in. It is an odd number, some strange odd number, and it doesn't even divide by 3 to give you a perfect square factor. It's probably not going to be reducible.
Let's see. I will hit a fraction bar. Okay.
And it's a -1 plus minus. Where's that plus minus? Plus minus the square root. Use the square root, not the nth root, of 253. And on the bottom, what have we got?
A 6.
6. And that's that.
Notice we're about, when I say okay, my grade is going to change from a 93.51 to 100.
Say okay. And sure enough,
there it is. So I'll say save it. And let's get out of this, and
let's go back to this. Let's mention once again that last question where the coefficients were fractions. I recommend you figure out what can you multiply 3 by to cancel out those fractions.
I know we're about out of time, or we've spent way too long on this, but let's look at this and say similar question, and just tell me what can we multiply this one by. What would you multiply? I'll give you a hint. It's either you're going to multiply by 3 or a 15. What are you going to multiply 3 by?
You need a number that will divide evenly into that.
And we'll completely cross-cancel both of these denominators. Well,
you want to cancel a 3 and you want to cancel a 15.
It's going to have to be a 15. Okay? Well, I'm not going to do that one. I will just say, let's get out of here, save it, the best scores. And we are done. So, Tim, move closer and say bye to everyone. Bye everyone. Hope
you're all staying safe.
Bye.
Bye.
Oh, let me see. How do I stop it? Right there.
Did you stop it?
I think so. For a moment, I was terrified that I had it. No, it's still.
Yeah, don't be.
Oh, I was worried that it hadn't been recording. It's still recording. How do I? Okay. Okay. Close that.
Okay. I can't get this there. Let me close that. Where's that?
It's right there.
Like this.
Okay. Oh my gosh. Wait. Are you sure what to stop recording and close?